Welcome, friends. So, we are discussing network theory, module 4. Module 4 is all about network solving techniques. So far, we have started with this module that is potential divider. Then we have seen current division rule, how a current can be split into two branches. Thereafter, we have seen delta and star conversion, star to delta and delta to star conversion equivalently. Moving on, we have seen also Kirchhoff's current law and its application to nodal analysis. And finally, we have seen Kirchhoff's voltage law and its application to mesh analysis or loop analysis. Now, this is a fresh session. Today we will discuss some more techniques with which we can solve different network problems. That means current flowing through any branch or potential drop across any branch we can evaluate with the help of these useful techniques. So let us proceed. So we start this session with a very useful technique. It's called source transformation technique. Now this technique is all about if we have a voltage source, E in series with a resistance R, then this combination, that means we have a E that is voltage source, and we have a resistance connected in series with the R, and the rest of the network, it's irrespective, that is it does not matter. So irrespective of the type of the network, if a voltage source and a resistance R is connected in series, then this combination can be converted into the equivalent, is converted to an equivalent current source I, and parallel with the resistance R. So this is so voltage source in series with R, that can be converted into a current source I in parallel with that resistance R. So voltage source is series with the resistance, equivalently converted to a current source in parallel with that resistance. So this is the value of I, it should be E by R. And what should be the value of voltage source? It should be I into R. So this is a very useful technique through which we can solve many network, or we can reduce network problems very effectively. So in gist, a voltage source in series with R can be converted into current source in parallel with R, where this X and Y are the any terminals of the network. That means across XY is the other components of the network. So irrespective of the, that is rest of the network is here. So if the rest of the network is connected in this fashion, a voltage source with a series of R, then the same network can be represented as a current source with parallel to the R, where I is equal to that voltage source divided by the resistance, and this voltage source magnitude will be current into resistance. So this is the philosophy of source transformation technique. So let us solve one problem. Let us try to solve one problem with this. Let us we have this figure 11. Okay, reduce this figure 11 to a voltage source in series with a resistance between terminal X and Y. So this is two terminals, terminal X and this is terminal Y. So we have various voltage source or current source are connected. We have various resistances. So with respect to X and Y, one should do this. This is X, this is Y. So what will be the value of this voltage source E, and what will be the value of this current resistance R? So this is E equivalent and R equivalent. One should evaluate E equivalent and R equivalent, right? So this is all about. Now let us solve one by one this problem. If we try to understand, let us first see this configuration. It is, what is this? It is a battery of 9 volt source is connected in series with 3 ohm source, right? So this can be converted into a current source. This can be converted into a current source. The same resistance 3 ohm. Now this current source value will be 9 by 3. 9 volt by 3 ohm, that will be equal to 3 ampere. So this source or this combination 9 volt in series with 3 ohm can be converted to a current source of 3 ampere. Why 3 ampere? Because 9 volt by 3 ohm is 3 ampere in parallel with this 3 ohm resistor. Now please look that this is plus, this is minus. Okay, that means the battery has got higher plate is at right hand side, so that is why the current direction is taken in this way. Because this current, this voltage source or battery will inject a current in this direction, right? In this direction. That is why when you convert this is equivalently current source, then the direction should be properly taken. So this direction and this direction should match. And this combination, if you see 9 volt and 3 ohm, this combination is connected across X and Y terminal. So you can say this terminal X and this terminal Y. So moving on, if we go for the next part, again we can see the similar structure or similar part, that is a 2 volt source in series with a resistance of 1 ohm. So the same thing can be done, that is same thing can be done. So this 2 volt source in series with 1 ohm, this can be done with a current source in parallel with the 1 ohm resistor. In parallel with the 1 ohm resistor. So what will be the current source value? It is 2 volt by 1 ohm. 2 volt by 1 ohm, it is equal to 2 ampere. Now why this current direction is from right to left? Because the higher potential is at left hand side, so it will inject a current in this direction. So that is why this current direction is just opposite with that of the first one, and this assembly is connected across the terminal X and Y. Now moving on to the next assembly, that is, you see this assembly, this is 5 ohm in parallel with 2 ampere current source, right? This is 5 ohm in parallel with 2 ampere current source. So now you can convert it to an equivalent voltage source in series with. So this combination can be converted into a voltage source, that is this, in series with a resistance which is equal to 5 ohm. Okay, so these two nodes are different nodes, and to the left of this node we have another 5 volt source connected here. So if we name these two nodes are M and N, so this node is basically M and this node is basically M. This node is basically N. So across M and N we have a voltage source. Now what is the value of this voltage source? It is current into resistance, that is 2 into 5, that is 2 into 5, which is equal to 10 volt, which is equal to 10 volt. So 10 volt battery or 10 volt voltage source is connected with a series with a 5 ohm resistance, and with this we have another 5 volt source here present. We have another 5 volt battery, so this voltage source is 5 volt. So now this entire assembly is connected across X and Y. So this node is X and this node is Y. And remaining we have a 6 ampere current source alone. We have a remaining 6 ampere current source alone. So if we try to accommodate that, let me write. So this is 1 ohm, and last we have a 6 ampere current source alone present across terminal X and Y. So we have reduced or we have converted something out of this diagram. Again, if you carefully look, this current source, that is 3 ampere, this 2 ampere, and this is 6 ampere. This is actually 6 ampere. So these three current sources are connected across X and Y. So you see we can apply KCL here. So equivalently we can convert these three current sources. So this 3 ampere current source, this 2 ampere current source, and this 6 ampere current source, we can equivalently convert these three current sources into a single current source. Now magnitude of this current source will be 6 ampere, then 3 ampere should be in the same direction, so 6 plus 3, and you see this 2 ampere current is flowing in the opposite direction, so it should be minus, so it will be 7 ampere current source. It will be converted as a 7 ampere current source. Now again across terminal X and Y, across terminal x1 y, this 3 ohm resistance and 1 ohm resistance are connected in parallel. So we can convert them. So this resistance is nothing but 3 into 1 parallel. So it will be coming out to be as R equivalent 3 into 1 divided by 3 plus 1, which is equal to 3 by 4 ohm, which is equal to 3 by 4 ohm. So I'm repeating. So this 3 ampere current source, what is the direction of the 3 ampere current source? It is from x to y. So this is 3 ampere. What is the direction of 2 ampere current source? It is from y to x. This is 2 ampere current source. And what is the direction of 6 ampere current source? Again, it is from x to y. So the net, if you consider these three, so the net current flowing from x to y is 6 plus 3 minus 2, it is 7 ampere. So if you say this node is x and if you consider this node is y, so a net current of 7 ampere is flowing from x to y, and this 3 ohm resistance and this 1 ohm resistor are connected across x and y parallelly, so they can be converted or they can be reduced to form a single resistance. So when two resistances are connected in parallel, this should be the formula, 3 into 1 divided by 3 plus 1, so it will be 3 by 4 ohm. Now moving on, if you consider this part, so you see these two will be this voltage source, these two will be subtractive polarity. Why? Because these two will be subtractive polarity, because if you consider the plate polarity, this should be minus, this should be plus. Again, this 10 volt source, this should be plus, this should be minus. So minus plus, plus minus. So as per the polarity symbol, this is referred as a subtractive polarity. So if you reduce or if you equivalently represent a single voltage source by these two voltage source, it will be simply a voltage source of magnitude 10 volt minus 5 volt, that is 5 volt, and then 5 volt in series with 5 ohm resistor, 5 volt in series with 5 ohm resistor across the terminal x and y, right? Because they are subtractive polarity, minus plus plus minus, they are subtractive polarity, and since 10 volt source is greater, so the net voltage is 10 minus 5 volt, so the polarity of the x is plus and polarity of the y is minus. So in this way it is reduced. So if you convert again, if you try to use the source conversion technique, so it's the same thing. So the same the same thing can be converted into a current source. We have a current source. Now the direction should be in this direction. So the 5 by 5, which is equal to 1 ampere, it should be connected parallelly with 5 ohm. It should be connected parallelly with 5 ohm across the terminal x and y. So it will be 5 ohm. So we are getting two assemblies. So from this diagram we are getting two assemblies. First of all, we are getting a current source of 7 ampere. In parallel with 3 by 4 ohm resistance, 3 by 4 ohm resistance, and we are getting another assembly, that is a current source of 1 ampere, current source of 1 ampere, current source of 1 ampere is connected parallelly across, is connected in 5 with a 5 ohm resistance in parallel, and all these two assemblies are connected parallelly across the terminal X and Y. So this is what we are getting. So from this assembly again we can use this philosophy. So you see, with respect to X and Y terminal, with respect to X and Y terminal, with respect to X and Y terminal, you see 7 ampere current is flowing from X to Y and 1 ampere current is flowing from Y to X. So net current will be flowing from X to Y will be 6 ampere. 7 minus 1, it will be 6 ampere. Because 7 ampere current is flowing from X to Y here, and 1 ampere is flowing, 1 ampere current is flowing from Y to X. So the net current will be 6 ampere, 7 minus 1, 6 ampere will be flowing from X to Y. Additionally, we will have these two resistances. Additionally, we have these two resistances R equivalent. So R equivalent will be the parallel of, that is 3 by 4 ohm with 5 ohm. So R equivalent is 3 by 4 ohm with the 5 ohm, right? Because across the terminal X and Y, this 3 by 4 ohm resistor and this 5 ohm resistors are connected in parallel. So if you solve 3 by 4 into 5 divided by 3 by 4 plus 5, so you will get 15 by 23 ohm. Yeah, 15 by 23 ohm. So this resistance is nothing but 15 by 23 ohm. So what we have done till now, let us revise one by one. So we have first 9 volt in series with 3 ohm resistance, that is converted into a 3 ampere current source in parallel with 3 ohm resistance, right? So that is the first we have done. Secondly, we have done what? Secondly, we have done, again we have found that 2 volt source in series with 1 ohm resistance, then that is converted to a 2 ampere current source in parallel with 1 ohm resistance. That is the second step we have used here. So this is. Third, we have seen 6 ampere current source present alone. We have not disturbed it. Right? So this is the 6 ampere current source. We have not disturbed it. And lastly, we have seen 5 volt source, 2 ampere current source in parallel with 5 ohm resistance. So we have converted to make it 10 volt source. We have converted to make it 10 volt source in series with 5 ohm resistance. So that is here. So from there on, we have seen that, so the net current, we have seen that across the terminal X and Y, so this is X and this is Y terminal, across the terminal X and Y, the net current flowing is 7 ampere from X to Y, right? X to Y, and from there on, from here, we have converted this 5 volt and 10 volt source are subtractive polarity, so we converted them a single voltage source with a 5 volt source in series with 5 ohm resistance. So from there onwards we have converted using these three we have got this result. We have got this result shaded by green, that is 3/4 ohm in parallel with 7 ohm current source. And from this we have got 5 volt source in series with 5 ohm resistance. So again, when you convert it to a equivalent current source, you will get a 1 ampere current source in parallel with 5 ohm resistance. So from there, right, so from there onwards the net current flowing is 6 ampere. So the net current flowing should be 6 ampere, and the net 6 ampere current flowing, and the net resistance will be 15/23 ohm. So till this point we have solved. So 6 ampere current source, and 15/23 ohm. So now when you convert it again to a equivalent voltage source and resistance, so this voltage source must be 6 ampere into 15/23, which is equal to 90/23 volt. 90/23 volt we are getting. So this voltage source is nothing but 90/23 volt. Since the current direction is from X to Y, so the positive plate should be aligned with node Y and negative plate should be aligned with node X, and this 15/23 resistance in series with this. So we have seen that first we have got a very big network, large network, complex network, where we have several voltage sources and current sources connected in different fashion. So using this source conversion technique, we are able to reduce this very complex network to a very simplest form, that is a voltage source in series with a resistance. This is the simplest form of all across the terminal X and Y. So this voltage source is 90/23 volt, and this resistance is 15/23 ohm. So this is called source conversion technique. So with this I have discussed how a voltage source in series with the resistance can be converted to a current source in parallel with that resistance, and using that philosophy a very complex network can be reduced to a very simple form, a simple resistance, a voltage source in series with a resistance. So with this I am ending this part. From the next session we will start our first theorem, which is a superposition theorem. Thank you for watching.